Welcome back, Physical Science 20. This is the section 4.6 double displacement reactions video. And we just finished doing the single displacement reaction video, in which involved using an activity series to see if a single element replaces an element in a compound. And of course that involved looking at recovering metal ions that are in solution by making them solids through that displacement. If you look at double displacement reactions, what happens is that we form precipitates. So two aqueous solutions could combine together to make a solid compound in that solution. A precipitate is a solid that forms when the result of two reactions are solution, when those reactions are solutions, or those reactants are solutions. Chemists have found, for example, that sodium hydroxide is beneficial in making tons of precipitates with other solutions, and we'll see a summary of that in a chart in a bit here. So if we take a look, copper sulfate, sodium hydroxide, copper is one that reacts with hydroxide and makes a solid, and then the sodium and the sulfate just simply exist in solution. Okay, so instead of having a single element replacing an element in the compound, we have two compounds this time, and the elements being replaced or displaced as illustrated here. So it's like they traded places. Chemical reaction in which two elements from different compounds displace each other is called a double displacement reaction. If you look at the general form of the equation, compound AB and compound CD, in this case, you could do A replacing C or B replacing D, it doesn't matter. That order, as long as you have a metal replacing a metal or a non-metal replacing non-metal. So it's almost like a square dance. You have two couples and the partners change. So that is the general form of double displacement, and I made a mention of precipitate reactions, which is one type of double displacement reaction. If you look here, make sure you highlight this. We could have the formation of precipitates, we could have the release of gases, or we could have the solution becoming neutral. So in other words, an acid-base reaction. So those are the three types of double displacement reactions. So we'll look at precipitate reactions in more detail here. If you take Chemistry 30, we'll do that in more detail. Okay, so when two solutions react, positive ions, or cations as they're referred to, in one solution attract and bond to negative ions, or anions, of the other solution. If the new compound precipitates, it must be only slightly soluble. In other words, only slightly able to dissolve in water. So we could say slightly soluble, for all intent and purpose, it doesn't dissolve, it forms a solid, a precipitate. Before we can predict which compound precipitates, we need to understand some key ideas related to solubility. So solubility, first of all, we look at a solution. A solution is a homogeneous mixture. Homogeneous implying it has one phase. So it could be a clear colorless solution or a clear solution that has a specific color. It has a solute dissolved in a solvent. For example, a salt solution has salt dissolved in water. Solubility is defined as the quantity, how much solute that you can dissolve in a given quantity of solvent, of course at a particular temperature. The solubility of a solute depends upon the bonding that occurs, the states that the substance is in, and of course, as I mentioned, the temperature. All substances dissolve in water to some degree. Chemists describe substance as very soluble or highly soluble, which means it dissolves. If a significant quantity does dissolve, a substance that does not dissolve well, so for example it exists as a solid in a solution, is referred to as slightly soluble. In the equation of a precipitate reaction, this symbol S refers to as the solid or the precipitate. Aqueous, if it dissolves, it's AQ, aqueous, meaning that it dissolves. Predicting precipitates. Selecting the correct reaction to precipitate metal ions from solutions requires some background knowledge on which metal ions are soluble and which are not. This information is summarized in a solubility table. So possibly in Chem 30 you will do a little lab in which we come up with results in which you could make a table like this. Before we look at the notes there, though, let's take a look at a few more things. This table is a summary of the combinations of cations, or positive ions, and negative ions, or anions. It tells us the combinations of ions that produce compounds that are very soluble and compounds that are only slightly soluble. For example, the table states that all hydroxides of group 1 elements are very soluble. And the group 1 elements, I want you to make this note, they're the ones that are in the far left-hand vertical group of the periodic table: hydrogen, lithium, sodium, potassium, etc. So that's what I mean by group 1 in this chart. So if we look at this, it's kind of backwards in that you look at the negative ion that's present and the positive ion that it's with. So for example, if I look at sulfate, most things with sulfate, if I look to the left here, are very soluble. They dissolve in water. They're aqueous. But there are some exceptions. Calcium, barium, strontium, etc. Those ones do not dissolve. They form a precipitate, so they would have the solid designation. Okay? So whatever these ions with this side dissolves, aqueous. If it forms with one of these ions, does not dissolve, it's precipitate or solid. Nitrate is an interesting example in that everything that is with nitrate is soluble. So we won't get an exception there. We won't get a precipitate with nitrates. And if we go down in the chart, we get to a point where the chart is reversed in that most things form a precipitate or are solids with carbonate, except the group 1s and ammonium. So carbonate is a precipitate, is a solid. It's very slightly soluble, barely any dissolves when it's with calcium, let's just say. But if it's with lithium, it's soluble. So that's how you read that chart. Make sure you get these extra notes in here because it can be a little bit confusing with the various soluble and exceptions. So this side, soluble, this side, not very soluble. This side here, slightly soluble, this side, soluble. And we'll take a look through some examples how to use this chart in more detail. Okay, so selecting a reactant to produce a precipitate. How can we treat water contaminated with toxic metal ions? We can precipitate the ions out of solution. The solubility table can help us choose an appropriate reactant. We want the reaction to produce a compound of the toxic metal that is only slightly soluble, because slightly soluble means precipitate. It's a solid in the solution. Okay. To remove a range of metals, chemists select an anion that forms a slightly soluble compound with as many metals as possible. In practice, soluble sulfide compounds are used. And earlier I mentioned the hydroxide group. And if you look at hydroxides, hydroxide with almost everything is a precipitate with the exception of a few things. The group 1s, calcium, barium, and strontium. So at the beginning there of this video where it talks about hydroxides, it's one of these 4 that form precipitates with many different ions. Chemists can also selectively precipitate certain cations from a mixture by using differences in solubility. For example, the solubility table shows that silver chloride is slightly soluble, but copper 2 chloride is very soluble. So, and also here, notice I got some green stuff here. We have analytical research chemist. Later on when we're researching for careers, you could pick that if you like. But anyway, let's get to the task in hand here using that solubility table. So it says here, so we have 2 ionic compounds, potassium chloride and silver nitrate, combined together. Do we get a precipitate, and what is the precipitate? So when you see this, potassium chloride aqueous, silver nitrate aqueous, think of it like this. Aqueous means they're dissolved, they're pulled apart, they exist as ions. So silver nitrate exists as Ag plus ions and NO3 minus ions floating around. Potassium chloride exists as potassium ions and chloride ions floating around. The question is, does silver combine with chloride to make a precipitate? Does potassium combine with nitrate to make a precipitate? We'll have to see. So when they change partners, so to speak, are one of these a precipitate? If we look at potassium nitrate first, nitrate with potassium. Nitrate, let's see, where would potassium fall? Oh, wait a second, there's no exceptions here. So nitrate with anything, including potassium, is aqueous. No precipitate there. If we found that silver chloride doesn't form a precipitate either, guess what? There's no reaction here. It would be just NR designated. Silver chloride, though, let's look. Chlorides and the other ones, the other halogens that are in the chloride group, for example, fluoride, bromide, etc. So where does silver fall? Oh, there it is right there. So if it had been on this side, it would be aqueous, dissolves, but silver is on this side, meaning that it is only slightly soluble. It forms a precipitate. It is solid. So we would write that equation like this. That silver chloride as solid, and potassium nitrate, it doesn't react. It's just simply aqueous. So don't forget, the physical states are important with these ones, so you can see which one is the solid. Okay? I think we'll stop the video right there, and we'll go on with part 2. With that, we'll look at another example here, and then we'll have some time to try some of these ones. Okay? We'll see you again.